Our project is called the Social Distance Sensor. The teammates are Zach, Steven, and Silvia. Next. The pandemic and the CDC recommendations of have a conscious effort to maintain 6 feet apart is what inspired this project. And this project has an easy reminder that includes the distance display, visual and audio cues, all built in one. Next slide. For the requirements, it has a ultrasonic sensor that emits waves, and it basically uses this to detect the distance between people. The display shows the distance between the user, and if the person is too close together, it will display a warning and the distance and the noise that comes built in. It is able to be activated by a push button, and this is a good feature because it doesn't emit a constant noise, and it includes a red LED light as a visual cue. Next. The system design has an input, which is the ultrasonic distance sensor, which I mentioned previously, and is activated by a push button. The output will be the LCD display, the LED light, and the buzzer, which emits signals. And it's just a message when it's outside the 6 feet, which is a safe message. And within 6 feet, the buzzer and the alarm message will go off, included with the red light. Next.
So next we have our components list. The major parts being on line 2, we have our ultrasonic distance sensor. 2 lines below that, we have a 10 kilo ohm resistor for each of our resistors in this circuit. Below that, we have the potentiometer, which is used to power the LCD. And then below that, we have the piezo, which is the buzzer in this case. Next. Next, we'll go over the assembly and basically show what's what. So in the upper left-hand corner, we have our ultrasonic distance sensor. To the right is the piezo. Below that is the push button, which powers the piezo and red light. And then to the left, we have the potentiometer, which powers the LCD, which is right below that. Next. Here's a pretty simple flowchart. So once we start, we read the distance sensor. Then we ask, is someone within the range of the sensor, which is 6 feet in this case? If yes, the push button, we also ask, is the push button on? If that's also yes, we sound the buzzer, light the LED, and display move away. If no, we turn the buzzer and LED off. And then we go back to our first question. If the answer to that is no, we display a clear message. That all gets fed back into another read distance sensor statement, and then the cycle repeats itself. Next. So here's our code. We'll go over the major components real quick. So to start off, we include the liquid crystal library, which is for the LCD. Below that is a bunch of constants to make sure that the LCD works. And then in our setup, we display a welcome message with the LCD, just to show that it's working as intended. And then below that, we have a bunch of setup for our pins. Next. So here's the beginning of our void loop. Essentially, the rest of this code is bracketed off by the if statement for the button. If it's on, things work as intended. If it's not, everything is basically shut off. Next slide. So here's the main if statement for this. The distance sensor reads in centimeters, so that's why it says 182. But on the display, we convert that back into feet for the user. And if someone is within that 182 centimeter range, we display a warning, move away sign. We also turn on the LED and the buzzer. Next slide. And then the other half of this statement, if they are outside of that range, it's all clear. And we also turn off the buzzer and the LED. Next.
Here's the integration of our circuit. Main things to point out, I rearranged the components a little bit to make it a little easier to put into the pins of the Arduino. To the left of the distance sensor, we have the buzzer. That's really the only biggest difference. Next, we have our test protocol. As you can see in our videos at the end, all the tests work. We test each component and put it in the videos. Here's our Tinkercad simulation. We have the code here, the documentation, variables, setup. We have our loop here at the bottom. We start the simulation, the LCD turns on, use the potentiometer, turn it on and off. We set the distance close enough, turn on the push button, the buzzer sounds, tells you to move away, the LED turns on. We move far enough away, press the button, nothing happens, we're all clear. Here's our actual Arduino circuit. The turn it on, plug it in, the LCD turns on. You can use the potentiometer to turn on and off the display. If nothing is in front of the sensor, turn on the button. We're all clear. We're more than 6 feet away. If we stand too close to the sensor, press the button. Tells you to move away, tells you the distance you are from the sensor. The buzzer sounds and the LED turns on.